We will be doing example 1. Are these functions inverses of each other? So we'll be using the algebraic way of proving if they're inverses by compositions. So we're going to start by finding f of g of x and see if that's equivalent to x. So it would be f of g of x is 5x plus 3 divided by 2. And then we'll take that and plug it in wherever there's an x in the f function. So it'll be 2 times this whole quantity, 5x plus 3 over 2, minus 3 over 5. So don't forget the rest of the part of the function f of x. Now the 2's cancel there, so that'll be left with 5x plus 3 minus 3 all over 5. The 3's cancel, and so it's 5x divided by 5. The 5 cancels, and you are left with x. So f of g of x is equal to x. So that's good. Now, if it didn't, we would be done and say they're not inverses of each other. But since they are, we will continue and find now g of f of x. So we'll switch it around. So now we'll do g of, and then the f function is 2x minus 3 over 5. So wherever there's an x in the g, we're going to plug in this expression. So it'll be 5 times 2x minus 3 over 5, and then that's all minus 3 over 2. So 5 times 2x minus 3 over 5, that's supposed to be a plus 3 divided by 2. So the 5's cancel. That leaves us with 2x minus 3 plus 3 divided by 2. The 3's cancel, so 2x divided by 2. The 2's cancel, so it is equal to x. So are these inverses of each other? The answer is yes, they are inverses. F of x and g of x are inverses. Because f of g of x is equal to g of f of x, which is equal to x. So that's the reason why they are inverses of each other. The next part that we're going to be looking at is we're actually going to find inverses algebraically. So we're not going to prove they're inverses on this one, we're just going to find them. So on the first one, f of x is equal to the square root of 2x minus 1. So what do we need to do? We need to replace the f of x with y. We need to exchange or interchange the x and the y value, and then solve for y. So how do we get, you just got to work backwards. You got to get rid of the square root, so we square both sides. You add the 1, and then divide by the 2. So that leaves us with y is equal to x squared plus 1 over 2. We do want to write it as the inverse. So we're going to change it back to function notation, f of x, but we're going to use that negative 1 as the inverse, is equal to x squared plus 1 over 2. Now I want you to look at that for a second and see if you notice anything that we need to fix. So the domain of the original function was all values greater than or equal to 1/2, and its range was all values greater than or equal to 0. Well, why does that matter? Well, the inverse had an x squared. So if you remember, a quadratic is a parabola. Is that a one-to-one function? No. So we have to have some type of restriction here for our domain. So what values of x must we only include? We can't include all real numbers. So if you look here, the range was all values greater than or equal to 0. So our domain for the inverse must be all values that are greater than or equal to 0. So that might be something we need to work on in terms of identifying that, but remember, they have to be one-to-one functions. The original one, f of x, was. The inverse, when we solved it algebraically, was not, so we had to fix it. Alright, let's take a look at example B. G of x is equal to 2x minus 3 divided by 5x plus 2. Alright, with the second example, we'll start it the same way. We will say y is equal to 2x minus 3 over 5x plus 2, replace the x and y, exchange them out, so x is equal to 2y minus 3 over 5y plus 2. Now this one has two y values in it, so we're going to have to see what's going on here, but let's first just go ahead and take care of some things. Let's get rid of the denominator, so we'll multiply by the quantity 5y plus 2, so that'll be x times 5y plus 2, is equal to 2y minus 3. Let's go ahead and distribute. So 5xy plus 2x is equal to 2y minus 3. Now normally when we have two y's in the problem, we want to get them on the same side. So let's do that. Let's subtract the 2y to this side. Let's also move the 2x, since we don't need that, since it doesn't have a y in it. Let's subtract the 2x to the other side. So we're kind of doing two things here. So that leaves us with 5xy minus 2y, and we're also going to subtract the 2x, so minus is equal to negative 2x minus 3. Now, with something like this, we would normally try to combine like terms, but you can't combine them. So what is another way that you can get one y from two y's that are being added? Think about that for a second. All right, so if you figured it out, we use the distributive property, or what you might call factoring the y out, and you're left with y times 5x minus 2. Well, why is that helpful? Because now we have one y compared to 2, and then it's y times that, so we can divide everything by 5x minus 2. So we get y is equal to negative 2x minus 3 over 5x minus 2. So the inverse, g of x, so g of x, the inverse of g of x is equal to negative 2x minus 3 over 5x minus 2. And then that is the inverse of the original. Now, this one doesn't have a restriction in terms of the domain. This is a one-to-one function. They're both rational as well.